Okay. Good evening, everyone. I hope you're doing great. Great. You remember we talked yesterday about artificial intelligence and the relationship that it has with machine learning. We said what actually happened. Let me just run this. Yes. What actually happened in 1996 was using artificial intelligence, early AI, which was excel in just one task and could do just, for instance, playing chess and not everything else. If you wanted to do the other thing, you needed to, you needed to write the whole code all over again. We said that project was Deep Blue, you remember? And we wanted to find something that doesn't need to get changed every time that you change the problem statement. Like what? You want to play Go game. It's a kind of East Asian game, similar to chess, but simpler. And you want to use the same strategy, the same algorithm to play an Atari game. Technically, the answer for that is machine learning. Machine learning is for writing one program that can solve a number of problems without needing to be rewritten. Like Go game that you see here, you can play Atari games with. And then we said the idea of machine learning is learning from samples and examples rather than relying on hard-coded rules. In traditional form, we had rules and data. And we said for that, guys, can you please just, yeah, thank you. We said for that, we have A equal to 10, B equal to 2, and when we say C is equal to A plus B, it's going to show you 3. So we have input, we call it data. We have rules for this one is summation, and we expect to have the output, which is adding A plus B, right? What about this one? Machine learning. In machine learning, you say, okay, I have data like A is 10, B is 20, and I have the answer 30. I want you to guess what is the regulation. But don't get me wrong, it's not just one sample. We go through hundreds or thousands of samples, right? And this is just one simple example. We want to discover, okay, the relationship could be summation, maybe, we don't know. But we have to go through lots of examples and to have the most accurate rule. But why we need that? I'm going to answer that question a little bit later. Imagine that if you want to write a kind of old-fashioned form of programming, the traditional way of developing, we need to say features that we are going to consider to distinguish between apple and orange. Could be like color ratio maybe, size, shape, weight, anything. But the problem is, if you define all those features, all those mechanisms, if you just simply change something as simple as color, or you replace them with 2 different fruits, then the algorithm that you define, it doesn't work for a new problem statement. And that's the cause of the issue. We need something more general. As you see, the title says, well, the description says, how about writing a program to handle black and white photos or different other images? We can consider machine learning as something like a function. In function, you have some inputs, let's say x1, x2, x3, and you expect to receive an output result, label, whatever you want to call it. So here we call those x's features, and we call the goal the label that you have. Some places you see say goal, some places you see that they say label, different namings, same concept, right? So you can look at machine learning as a sort of method that receives some inputs like x1, x2, x3, and so on, and it's going to tell you, hey, this guy is an apple or orange. This email is a spam or not spam. Does that make sense? So let's go a little bit further. Listen to this. It says that machine learning is all about algorithms that can define these rules for us. And for that, we are going to train a classifier. I want you please spend a few seconds and tell me what classifiers are. Believe it or not, people finish school, advanced machine learning, deep learning, and if you ask them what is classifier, they have no clue. They have no clear definition. How about this? You're going to be the first with a Vadud, I forgot his name. Vidor, I'm sorry. Vidor. I had students with the name of Vadud, and so that's why. Vidor, you're going to be the first person who's going to help me to find the answer, but how about spending 1-2 minutes searching what classifier is, please? Pardon me? Okay. Govind. Gaurav. Why I always say Govind instead of Gaurav? And 11. Please give me a second. Vidur. Please, Vidur, can you just.
Classifier is basically a set of descriptors that you put an input group, and if it matches the description, it will classify it, like classify the input based on.
Wow. Wow. Honesty. Awesome. Explaining better than me. I'm not exaggerating. Exactly. So, guys, I didn't learn. I'm a slow learner. I need 2-3 more explanation. Yes, Matthew, please.
It's a really complex way of sorting things.
Complex way of sorting. Okay, just let's change our hats. You know the topic, but if you tell that to somebody, complex way of sorting it. Yes, please.
Like you're given a set of inputs, they look at the input, and then it says whether it fits under a category or.
Actually, I'm very happy that you said that word complex, because we are gonna use that in a few minutes. Why in data sets that we deal in machine learning, we technically face complex. Ali, you wanted to add something?
I was gonna say, like, if you have like a bunch of emails and you want to sort emails that are spam and not spam, the classifier you look at like the subject, information, and like email, and then it will kind of like what exactly.
You see the difference between original and copy is exactly here. We had 4 different explanations, and everyone explained differently, and they completed each other, like paragraph 1, paragraph 2, paragraph 3. Yes, Maharish.
Can I explain?
Please.
So, this slide we teaching a computer. First we show an image of rules and say this is the computer learns. Then we're gonna test with some more data, and after that, if computer choose the correct answer, we can give a feedback, positive or negative, on what the result shows. And at the end, the computer is going to learn this is the apple, this is the banana, this is the
I very much liked it. Yes, Mahar. Yes, Ali, you wanted to add something into it?
Uses the little trees. Pretty much like get the output like as quick as possible and as accurate as possible for like all the possible consequences that occur. So
Lovely. Awesome. Yeah. Let me just summarize what I learned from you guys. Imagine that we have different columns, and for that, I'm going to show you one example that I provided you. So imagine that we have different columns. Based on the features of a flower type, actually, irises. And based on those features, we want to say if that flower, that specific iris, is Setosa virginica or versicolor. Huh? We want to classify them based on those features. Technically, classifiers, as all of our friends mentioned, are algorithms, are models that they take features or those columns, the data set, and supervised us to a specific label. I repeat it. Those are the rows that are going to supervise us to a specific label. Huh? Like, I learn if I have these features with these values, it is Setosa. I go down. If I have these features, it is a versicolor, and I go down. And if I have these features, they are virginicas, right? Now, my question for you is, these are the tasks that we expect to get from classifiers, providing data set, expecting labels. But right now, I want to ask you this question. What is the use of it? What is the use of, yes?
So like the other classifier, basically, like I think it's hard to look at something like for example, we have a 2-column utility classifier because it's like you can say, oh, if column A, the length of the petal is like you can average it from all of Virginica and all the other ones. You can probably do a rough estimation as to what kind of output it should be. But I think the biggest utility, say when you have like thousands of columns and you don't understand whether certain columns are more important features than other features, then these models can probably classify and find relationships that maybe we do not need to consider ourselves.
You brought it to another level. Actually, you not only say that we have data sets, but also the weight of columns could be different, and it wants to say which columns. That's awesome. Before I say my opinion about your the definition, let's hear from Harlan.
The use of a classifier is the ability to then have make a prediction on something that's not in the training data set.
Wow. So we want to get a formula for something that we haven't seen before?
You train it on something that you know, so for this example, doing 3 different types of flowers. And then once you have the model trained, you then want to use that classifier to then give it data it's never seen before and see if it can make a difference.
So, I mean, basically, it's like using a random range of unique data for each of the categories that we put. We try to identify, I mean, not us, but the machine is trying to identify which ones are in those categories. And in this case, as he said, like we're using a small data set. But if we go into a much bigger data set, like we can even use machine learning to identify different types of cancers in the body and teach the machine to show that this is for that and that's for that. So it's using that random range of data set for each of the categories to identify the problem.
The only thing that we need to discuss, the only point of disagreement that I have is the random,
No,
the word random. Yeah.
Of unique data set for that. So let's say Virginia is going to be from 6.3 to 6.7.
Oh, I see.
It's going to be random.
I got what you're saying. That's what I very much like this class, and I don't feel tired at all, because when I ask questions, I don't need that much. I just need to put those paragraphs together and the answer is already provided by you guys. It's exactly what you said. We train our model. First, classifiers are nothing but algorithms. I repeat it. Here's it. Classifiers are just algorithms. Classifiers are models. But when I say algorithms, in each algorithm when you implement, they have some variables. By default, there is no value for those variables, right? And based on the samples that you fit to your system, to your model, to your algorithm, it is going to change those values, those variables, and adjust it to your model. I repeat it. It's a raw algorithm, raw model. Imagine that I say decision tree. Based on every single line, every single sample that we have, it's going to adjust the model, the decision tree, towards the goal that we have to predict if that line is versicolor, that line is virginica, and so on. It's going to modify it. Okay. Great, yes.
Professor, if there is some like really rare cases when the two data are similar but the others are different. For example, versicolor and Sentosa are like two different flowers, right? But they both have the same data. How it's going to differentiate?
It's going to be the noise for the system. Right? So we are not going to find always we have error issue. Allow me not to get to that now, because that is sophisticated topic. For now, what we expect to understand from classifiers are algorithms that are going to learn from the samples, and they're going to predict unseen data, and you're going to hear it from me 100 times from this moment, especially in the next semester. We use unseen data or test data a lot. Okay, you can just consider the classifiers as something like a function. We have fx, x could be x1, x2, x3. We have some variables, features, that they are going to supervise us to one specific label. That is why we call these type of algorithms supervised learning. So supervised learning happens when we have some features that are going to bring us, supervise us to specific label, a specific label. This is not review of what we talked yesterday. This is looking at it from different angles. So that's why I repeat it. Imagine that we have one algorithm here. The whole idea is saying that you said, Reza, if we want to play chess, we're going to use this. And if we change our mind, we want to predict the weather, and use exactly the same algorithm. We could, if we want to see if an email is spam or not spam, we use the same algorithm. So this guy is the same. This guy is, what is this? Don't say Apple. A data set. A data set could be different. You just need to change the data set, not the algorithm. And that's the whole idea of having machine learning. In machine learning, you don't touch the model. You change the data set. Does that make sense? Okay. So the same algorithm can be used for spam or non-spam. And look at this. The technique to write the classifier automatically is called what? Supervised learning. And it begins with examples of a problem you want to solve by finding patterns in these examples. Just coming late is another story. I got disappointed to tell on time. But standing in the class and looking at horizons, sit. Thank you. Okay, everybody, if you please open your Colab and then say import scikit-learn and run it. If everything works fine, let's give me a signal. Let's see. Thank you, Rachel. Let's see. Okay, look at this one. We have 3 phases in running one machine learning algorithm. And those 3 phases are: first, collecting data. Second, training our classifier. Third, predicting what's going to happen next. Unseen data, as Arlen said. Right? Arlen, you said that, right? Yeah, okay. So we have 3 phases: collecting the data. Imagine that we head to an orchard and we pick some different fruits, just apples and oranges. Apples, 140, 130, smooth, while oranges, 150, 170, bumpy. What can you infer just based on the weight? What can you say?
Apples are under 150.
Yeah, in general, we could say apples are lighter, oranges are heavier. Yeah, and in this, for example, guys, if we have just one column, it's enough, but life is not like that. This is just for example. Imagine that if one fruit is 110 and it is smooth, what is that? What is that fruit? Excellent. And what if it is 165 and bumpy? Definitely, right? So you got it. We want to find a model. We want to find a model that works with this one and can work exactly with something, a data set totally. I told you yesterday that this is the input of the function features of the model. And this is the output of the label of the model. Does that make sense? And 140 is smooth apple, 130 smooth apple, 150 bumpy orange, 170 bumpy orange, clear. And I said that this guy, sorry, doesn't like strings very much. So we replace smooth with 1 and bumpy with 0. We replace apple with O, 0, and orange with 1, right? And the next phase is training, but you had a question. Lovely, I'm sorry. I give you mark just not to dishearten you. Yes. Yes, thank you. Look at this one. Training. Please look at this line. Classifier. Guys, please correct me if I'm saying nonsense. Can we say decision tree is a classifier? Yes. I was about to give bonus mark to you, then you're going. First you said yes, and then no. So, Alan, you say yes or no? Yes. Okay. You see, he got the bonus. I'm sorry. Yeah, just we had only one. Okay, classifier. Guys, classifiers could be as simple as this guy. What is this? A simple if then else. Let me ask you something. Imagine that we have just only one column. And in that column, can I have your attention? This is super important. If you get that tiny thing, then you're gonna understand the whole idea of this one, the shadow. If you have just one column and we have different numbers, imagine that we have hundreds of luggages and we have just one regulation. If a luggage is heavier than 32 kilograms, we say heavy. If it is not heavier than 32 kilograms, we say it is light, it's not heavy. Is it clear? In that case, do you think that, first, is it possible to use machine learning? Yes or no? Is it efficient to use machine learning? What do you suggest instead of machine learning? What is your name? Mehad Jayesh. Mehad Jayesh. Exactly. Guys, if you have only one column, who said complex? Matthew said it's a complex kind of thing, right? And that's why I said, Matthew, we're gonna get to that definition in a few seconds, a few minutes. And now it's the time. If it is simple, if it is just one column, you can use if then else. If it is more than one column, then the combination is not that easy. And finding the spot that you have to say, okay, less than which number, greater than which number, we should put that spot. This is the task that, for this example, decision tree algorithm is going to provide for us. Does that make sense? Okay, longer story short, training classifier. Well, classifiers are algorithms, and training classifier is a process. We're gonna get to that. Do we have only one machine learning algorithms? Do we have only one machine learning classifiers? No, we have tons of them, right? We have k-nearest neighbors. We have random forest. we have gradient boosting, we have artificial neural nets, support vector machine, logistic regression, and you name it. We have tons of them. Huh? It is like you have a body of a car, you take out the engine, you put a new engine and see if it goes faster or not. Really, I think that you do not feel happy about what I said. What is the comment? Sorry? Unrelated. Oh, I thought that I said something wrong.
No, it's frustrating.
Oh, don't worry. Yeah. Because, guys, there are tons of things that I don't know, and I'm eager to learn from. Okay? If you see that sometimes I say something that doesn't make sense, tell me. I repeat my example. We have all those engines. We take those engines out of the car, replace it with a new engine, and we say, okay, is this car going faster or not? You see that? So different classifiers, and based on the result, you're going to say, in such cases, decision tree works better than random forest, for example. Okay? Guess what? I needed to teach advanced programming at Centennial. And one of the weeks, I needed to teach machine learning using C#. I was like, oh my Buddha. What should I do? I started learning. Guess what? It was actually super intelligent way of solving these questions by C#. I never thought that somebody implemented. Do you know what Microsoft did? In Python, you have to replace it manually yourself and apply the prompters. Microsoft just it does the same job and compare all the models and tell you, you know, among 20 different approaches, this one is the best.
It's like,
You have to try it. You're gonna enjoy it. So I started seeing it, okay. The whole idea of artificial intelligence, machine learning, deep learning is not only Python. So we have other environments that they. Okay, no. Somebody tell me, what is this like? Yes, Anas.
It's gonna get the decision tree classifier algorithm around that.
We get decision tree classifier from tree. It's like Toronto, downtown, George Brown kind of thing. Huh? Okay, I got it. But what is CLM? Is it class? Is it a class? Is it a yes?
It's an instance of the model.
Why this class gives all the correct answers? Okay, awesome, Harlan. It's an instance, it's an object that we have. But the question is, what is that object? It's a classifier. Yes.
It's taken from sklearner. You import that at the top.
Yes, right. But my question is this CLM, this classifier is box of rules. The question for you is CLM already contains any regulations and rules inside it? Yes. Diego. And Peter. Yes.
So it doesn't come with any predefined classifications at all. We have to we have features and labels. Will be giving it those.
Let me give you one simple example. Imagine that you say if A is greater than N. Do you know what N is? Not yet. Right? You just said if A is greater than N, say it's greater than N, else say it's smaller. As simple as that. But whenever you say, please input the value for n, then it makes sense. If a is greater than 10, say it is. If a is greater than 15, pass. Else, something. Does that make sense? So technically, in this line, we say, hey, we have those kind of regulations, but we haven't initialized them yet. In the next line, we say, in the next, before getting to the next line, look at this. If we consider a classifier as a box of rules, we can say training algorithms are the process that provides those rules for us. Does that make sense? I repeat it. We have a classifier like decision tree, logistic regression, you name it. And then we need to define a process to shape our model, provide parameters for it. That is learning algorithm. And we are lucky that this object by itself has those procedures. So fit is nothing but finding patterns between features and labels, right? So again, fit is nothing but finding patterns between features and labels, yes.
So for example, what information it would pull from what we've given it here that it with labels equals 0 if the first value in features is less than 140? Is that something that it could do?
I swear that swear to God, that in 25 to 30 minutes, in a coloring picture, I show you what is the responsibility of this. 30 minutes. Thank you. And now we get to the point that many of our friends already said, especially I think that Harlan was the one who said, we create our classifier in order to predict unseen, right? Predict what is going to happen, what is the label for unseen data. Otherwise, hey, what is the usage of having these features, saying that these features are equal, that bring us those labels? What's the use of it? We need to use them for unseen data. Is it going to be always accurate in prediction? Yes or no? The more parameters that we fill with, the less accuracy we have. Imagine after all these years and having satellite, all those movements of the clouds, top of the clouds, everything that we have. Still, it says that the chance of shower is 60%. And it saves phases for them not to receive any critics, like, hey, I told you 60%, now that 40% happens, right? So we are not going to have always high accuracy, but we try to get there. Now we have that classifier in line number 5 that has the regulations. Now we can practice if it works fine or not. We're going to give another sample, which we do not have in there. Guys, if you test your data with one of the features that we have, you downgrade machine learning to a lookup table. Does that make sense? It's like you use like Excel F7 search, right? Control F. Here we have something that we do not have similar into our features, but we want to say what is the output prediction. Look at this one. Yes, it says it is orange. And please get to this slide. If you copy and paste, and let me tell you, whenever you directly want to copy, at least I'm not aware of any solution for that. You need to bring it to, whatchamacallit, to a text editor like this, and then copy it again, bring it to pull up, and then run it. It's gonna tell you orange. If you just reduce the weight to 110, and I'm sorry, yeah, and you say the surface is smooth, what do you think that the output could be? Which is Apple, right? Okay, I run it, and you see that it's gonna show you 0, which is Apple, huh? Okay, guys, take your time. 1 minute, try this, play around with it, and please do not expect this, for example, does any miracle, like what if I just enter 110 and 0? We do not have that much sample examples to expect any accuracy, right? It's just 4 lines, 4 examples. Whenever you feel comfortable, please give me a signal. Just proceed. Thank you. Merci. Awesome. So let's wait for 30 more seconds. One bonus for which class are you? So coming late for the morning one, negative one. Okay, right. You are even. No. Okay. Can I ask you something, please? For this one, change the data set. I told you when we deal with a new problem statement, we just need to replace the data set, not the algorithm. So replace the above data set instead of gram for the weight, say horsepower, and instead of bumpy or what do we call it, smooth, say number of seats 2 or 8 or something like that. Can you please do that? Sport car 0, minivan 1. Okay.
Like in the Lakers, we outsource zeros and ones.
Like this. Okay, guys, do you see similar thing? I just made so 300 2 seats, 450 2 seats, 200 horsepower 8 seats, 159. And I said, let's say sport cars are 0s and minivans are 1s, right? So now if I say, how about 100 horsepower and 10 seats, what do you think? Minivan, right? So that's why, and you can simply guess, what if I just say, how about 400 and the number of seats just 1 or 2. Yeah, it's gonna be 0, sport car, right? Okay, let's spend 1-2 minutes because we are gonna get to the assignment right after this. Please just explain what you understood from this example to your friend. Yes.
Notice that if you give it the same value sometimes, it will, like especially ones that are ranked in weight, it'll return different things depending on.
I told you, we just want to have a feeling about what is happening. It's not a real data set. It's just 4 examples, right? So we're gonna see better results when we go to the next PowerPoint. And that one, we have a classical data set called IRIS. You're gonna see that. Good question. Okay, so the next question that you could ask is, what if instead of having these numbers, if we have something like, and we already, we have pictures. In that case, we use TensorFlow, or we have something like overlay model, which we call it Keras. It's not specifically a library per se. It's a kind of overlay that supports different libraries, including TensorFlow. And that's, look at this one. If the data that you have can be displayed in a table form, nice, neat, classified data set, we use machine learning. If it is something like images, like sound, voice recognition, and so on, the data set is not like different columns. We call them perceptual, right? So machine learning, the material that we learn next semester, is for exactly perceptual content. Now, the questions that we could face are, how does this work in the real world? How much training data do we need? And how is the tree created? And what makes good features good features? Let's have 8-minute break and continue sharp at 12 o'clock. And after that, I'm going to explain a few things. Awesome.
What time for joining?
This looks. Shut up.
Okay, that sounds. Meetings gonna go there. Well, that was really. And then usually.
Okay. So there are a few things that before we proceed and go to the next slide, I want to elaborate a little bit more on this code. Guys, what do you think? Is this efficient to write the data like that? Like features manually like this? What is your suggestion? Yes, Matthew. Using CSV. Oh. Did we use anything before? Did we have any example that we use CSV files?
Yeah, we use CSV files.
Okay, apart from the assignment you remember in President Hyde, that data set, right? Okay, how we can, that's the question. How can we make a CSV file? Everybody, please try this one. Just right click and choose new and say Excel. And let's say it's my data set, for example. And for apple and orange, the first column was weight and the second column was texture and the last column was what? Label, huh? The weights, as far as I remember, 150. Let's just get to 150 0. So we said 0 for bumpy. 150 0, it is orange. 170 and 0 again orange. And 130 smooth apple. 140 smooth apple, right? If you just save this one as a CSV file, here you just check and say CSV, and you check, we have different types of CSVs, and UTF is the most general. There's a chance that you save them with DOS or some other things, and you cannot open them everywhere. So if you just choose this one and say save, look at the shape. the right side is the CSV file, while the left side is the Excel file. Yes, Casey. Sorry. It is possible to do so as well, yeah. Yeah, but the most efficient way, that whenever we want to work with a real data set, we use CSV files or tables or queries. So we just fetch the data from nice, neat data set. But the question is, okay, imagine that we create a CSV file. I have forgotten how to fetch data from, I intentionally, yeah, I have chosen, I've searched for that before. Simply say how to, you see, how to fetch features from a data set from for a classification model. Add something like Python, CSV files, and so on. And if you do that, the second, in my search, in the second one, if you scroll down a bit, look at this. Now we know most of the lines. Here we say data.pd pandas. You see here, pd.read CSV file, that's the file that you want to read. Can anybody explain this one? We haven't taught this, but it's not hard to guess. Yes?
Permitting specific data,
Can you please be more specific?
like data dot ILOC,
Uh-huh.
ILOC application.
What do you understand from this part? That's perfect, yes. But what do you understand from this part?
Like that's for documentation.
Okay, yes.
Would it read every column from 0 to 20?
Every column from 0 to 20.
Every column from row 0 to
Just multiplied by -1 means the first one is row.
Oh, okay, so every
rows.
Okay, so like first.
Yes, it's rows,
Oh, okay.
and this is
So every
column.
row. Only column.
Yes, column from 0 to 20. And the same thing applies here. The Y, the label, is the last column. That is why we say -1. -1 is going to fetch the last column, all the rows. Does that make sense? So do you see how we can save everything in a file? Okay, and how we can fetch it? Look at this one. Here is the problem statement. Now talk to your friend or friends here and see what you have learned from today's session so far and how we can apply it to this part of the project, assignment number 2. File, save as, CSV. The first one, UTF. Now you have a new friend. You can talk to him. Sorry? Don't worry.
Anyway.
No. You can just talk to him. Yeah.
What is the actual code?
Oh, at Glasgow, didn't I say at Glasgow? I'm gonna say,
Thank you very much.
so at Glasgow for the previous one was, and now it is finished. I-230 for the previous one, but for the new one, forget about it. You can just, because you don't come to the original class. Yeah. For 11 to 2, the at class code is 1BXM. Can you please confirm if it works? Okay, thank you. Merci. 1BXM. I'm very fine. Good question, yes. Okay. Did you read the paragraph? One of the things that I saw a lot in previous submissions that people say, is it rainy or not? Yes, no, 0, 1. Is the weather good or no? Yes, come on. If that is the case, you just limit yourself to 5, 6 different possibilities. You know what I'm saying? If that is just weather is good or not, you have to say, for instance, if it is below 5 degrees centigrade, then I'm not gonna play outdoor tennis. If it is above 40 degrees centigrade, I'm not gonna play. If the amount of rain is something like 1 millimeter, who cares? But if it is 2 inches, then you have to worry about. You know what I'm saying? So yes, no, it's the worst kind of, even if you want to use, for instance, for something like rain, which is acceptable, but don't use it for everything. Yes, no, 1, 0, 1, 0. It's not going to give you that much accurate result. What are the columns that you think of? Rain, temperature, what else? Type of, okay, that could be wind. And wind, please do not say I had that. Windy, yes or no?
Should be like,
If it is above something like, for instance, 30 kilometers, then you can't control the ball that much. Huh? So the best is to say, if it is above a threshold, no, I'm not gonna play, else I'm gonna play. So is it clear now how to define a table? Yes, Ali?
So when you find a table, like, would you like start off with the best case scenario and then you gradually go from the middle and then to the worst case scenario?
I'm not calling it best case, worst case. We have tons of examples, right? You can have 20 rows and the final column says, do you want to play? Is it possible to play? Yes or no, 0 or 1. Does that make sense? Based on those conditions that you have, the wind, temperature, and so on and so forth. Yes or no? Yes.
Can be a perfect day, but super windy.
So that's what I'm saying. In that case, if it is super windy, you cannot control the ball, right? then it is 0, no. Okay, that is one thing. If you can find a data set for such things, awesome, good for you. If not, you have to create a data set for yourself. The same thing applies to part 2, part B. For COVID, if you can find a data set, good for you. For instance, the symptoms that somebody has. Maybe the heartbeat rate, the sneezing or coughing, or the type of coughing, having fever or not, right? Non-stop. That's awesome. It's a very high level of energy. So you got it. So you need to have, for instance, 3, 4 columns. Now search, please, for. Okay, let me just do you a favor. Please just search in your sequence folder. So right now, search for having different data sets for COVID. Can you please just search? Okay, see and talk, guys, the whole intention to make sure that after this search with your friends, when you go home, you don't feel that, I can't just do anything about assignment number 2. I don't know why people found it a little bit confusing, why it is, I think, the easiest one. Okay, please search, talk to your friends, say, I found this data set. This is the worst that somebody could generate. So it is like fever, yes or no? Hey, come on. What do you mean? At least for this one, we should say temperature. If it is, for instance, somebody.
110.
Yeah, or I use centigrade. So if it is between 37 to 38, not a big deal, but if it is above that, or the tiredness of that level of being fatigued, what is that? Or blood pressure, we don't have that. Heart rate, we don't have that. So you see, this is not that much, I mean, great example, but even in something like Kaggle, we have such not very decent data sets, as you see. Okay, let's go to the next part. Listen to me. You don't need to hard code it. Which one do you prefer if I ask you to hard code your data set or to download it from a file, to upload it from a file, sorry. Why? Do you want this? Do you want this? Oven, right? I'm gonna send just to in the group. Now you have. Neha, Neha, you wanted to say your reason. Why? Or what else? Yes, Ali? Better readability. You can just easily detect, sort, take care of the noise in your data set. You can easily add, remove rows, columns. Awesome. So do you think that you have confidence to start working on this? The only thing is, actually, I said, please use 30% of the data set as the testing. This part is something that we are going to cover after the midterm. Actually, I want you to try your best, see if you can discover all these kind of details before I start explaining it. And I repeat it once again, that the midterm is going to be on campus. Please come to room number E321. I've mentioned I'm going to send a reminder.
It's on Monday, right?
Yes. Hoping that I'm not going to see, while there is always a chance that somebody says, Reza, I thought that this is online. Yeah, that's my nightmare, but that will happen. I should be prepared. Let's go to the next part together. Slide number 2. In this one, we want to use visualization, and I received a question about what if we have many number of columns? What if we have 4 just rows? Or you ask that, what if the value is not exactly aligned with those kind of things? So I said we need to have more data. See, please just read a little bit. Even wiki is fine. Wiki is more than enough. Read about IRIS dataset. IRIS. What is IRIS dataset? And what are the specifications of the dataset? Yes, but how many lines it has? Yes. Okay, read for 1-2 minutes in Wiki. One of the thing is, before getting into machine learning or deep learning process, first you need to get to know the nature of the data set that you're dealing with. So spend a few seconds. Done. Sorry. 50 for each sample, 150 in general. We are going to get to that. So good, thanks, Peter. Look at this one. What was the algorithm? What was the classifier that we learned so far, we used so far? Yes. Which type of classifier? Yes, decision tree. Let me just Mahyar, Peter plus Lucas. Decision tree. Can anybody name a few more algorithms, models? Yes, Lucas. KNN, K nearest neighbors. Yeah. Random forest. Linear regression. Yes. SVM, support vector machine. Logistic regression. Actually, that is machine learning algorithm, linear regression, but it's not a classifier, it's a regression. But surprisingly enough, logistic regression, opposite of the name, is a classifier. Yes.
Linear discriminant analysis.
One of the most famous one, artificial neural nets. You could say, how about convolutional neural nets? Yes. That is machine learning algorithm, but to be more precise, it's a deep learning algorithm. Yes. Okay, we have lots of algorithms, but we choose to work with decision tree for this one too, because it is easy to understand and easy to interpret. Technically, it is nothing but some nested if-then else's. And we are going to visualize it and see what is happening under the hood. So look, yeah, you already said all of these guys. And why we choose decision tree. It's easy to read and understand. And one of the few models that are interpretable by, do we have any machine learning or deep learning algorithm that we cannot understand? I could say we have some algorithms that are not easy to understand, like convolutional neural nets. Okay, this is Iris, and this gentleman, right before Second World War, he collected this. It's 1936. It should be somewhere here. Now I cannot find it. Oh yeah, there we go. So there's Ronald, this gentleman is Ronald, not you. So he found this data set, and well, he went to nature and just measured all those different types of iris flowers. And then the result is something like this. You see, we have 150 rows, 150 samples in 3 different categories: Setosa, versicolor, and virginica. The thing is, the samples are sorted. There's a good thing, there's a bad thing about that. We're gonna see it after the reading week, after the midterm. But look at here. How many features we have for this data set? Yes, exactly 4. Sepal length, sepal width, pedal length, and pedal widths, right? And we said that scikit-learn is not very much friendly with working with strings. So instead of Setosa, we are going to say 0. Instead of versicolor, we are going to say 1. And instead of Virginica, we are going to say 2. A data set I already have provided for you, so you can find it. Yes.
When I was checking out the Iris data set on ChatGPT, there's actually a way to just import the Iris data set through sklearn, which is interesting. Should we do that, or is that a feasible way to go about it, or would you prefer to use the file?
I'm going to explain that in 5 minutes, definitely. Thank you for bringing that. Awesome. If we go to the scikit-learn folder, you see that we have data, which one of them is Iris explanation, and we have CSV file. As Alvin said, actually we have a version which you can use the scikit-learn libraries data set. The scikit-learn guys are very friendly, providing some sample data sets, including Iris, MNIST, Fashion MNIST, and some more. Because there are some classical examples that we all use. We start there like hello world samples for us to start working with machine learning, hello world kind of thing. So you don't need to import them from other resources. You can simply import them from the library that they have provided for us. And we are going to get to there in no time. Harlan, you wanted to say something?
They also kind of include databases to use as like a check to see if your model's performing well. Like you'll know if like model performs at 95% accuracy on the Iris, so they include that the model accuracy, or is it just like ease of use at all?
They just wanted, you know, you want jump into one algorithm and learn it. You don't need to worry about, okay, where is the data set? How can I import it and so on? You have it there, you just use it. The good thing about the assignment is I ask you to use your own data set or to find something from Kaggle or the others. So you start learning how to import, how to upload using CSV files. Yeah, that's the whole intention. Good question, by the way. Let's go to the I'm sorry. In this set of slides, we try to import data sets, train our classifier. These are the steps that we did in apple and orange example. We are going to predict, that is the other thing that we did, but visualization is something that we didn't do so far. So for scikit, everybody, if you go to slide number 10, you can simply copy this part and here it is. Slide number 10. I mean, PowerPoint number 2, slide number 10 in PowerPoint number 2. You can copy and paste that. And please make sure if you just copy and paste and you run, it's going to give you something like this result. So if you get the same result, please, yes, thank you. Give me a signal, merci. Awesome. Bravo, James, right? Okay, what it said, as Colin said, from scikit-learn datasets, import load iris, and then you load that into a variable. The name should be A, B, C, whatever. But and then when you say iris.feature names, look, it's going to give you sepal length. Look at the sample that I borrowed from Wiki, and sepal width, and so on and so forth. And if I say, show me the iris target names, what is the iris target names? The labels. Setosa, versicolor, and virginica. And then if you say, show me the first data, you say data.0 and target.0, target label Y, whatever. If you say data 0, it's going to be 5.1, 3.5, 1.4, and 0.2. The first row of the data set, right? And what is the label for that? Setosa, which is 0. If you say, show me the target of the first row, it's going to be Setosa or 0. Does it make sense? Okay. You could simply say, for every single I in the range of iris target, which is 150, which is going to be 0 all the way to 149, totally 150 numbers. Show me the example person, the label, the last column. Person S, features, person S. Look, we have I, we have targets, which is going to show you the labels 0, zeros, 50 zeros, 51s, 52s. And then we say data I, which is going to be those, as simple as that. So it should be on slide number 11. Give yourself a few seconds to try it and see if everything is fine. See? Awesome. Thank you. Bravo. And by saying that, technically we learned how to import, and now we need to train our classifier. The thing is, look at this, this Excel that I provided for explanation. In the second tab of the, and you have it. You see, I told you the index of each row and row number. Guys, you never say row number 0. You say index 0. What's the first row, right? So that is why I mentioned index and row. So index 0 for the first row. You have those numbers 5.1, 3.5, 1.4, and 0.2. And look at that, Setosa, and in the green color said 0 because string kind of thing. Imagine that we want to train our model, and now you know what the train means. Means you want to make the model learn something, and whenever you see unseen data, it can work almost fine. Why I say almost? Because, again, example, weather forecasting, it can't be 100% sure. My question for you, what is the strategy? We only have 150 rows. What do you think we can do to have a model and test it on something? What is your suggestion? Yes, Matthew?
We split the data.
Lovely.
Segmented it into training data and verification data.
Bravo. We are going to take 3 rows out of 100. Look at those numbers on column J and column K. The overall number of samples are 150. We take 3 rows out. What is the result? 150 minus 3. We are going to have 147. We use 147 rows to train our classifier, to train our model, to train our algorithm. And then we are going to test on those 3 rows and see how accurate our algorithm is. Look at this one. What if I take all the 3 samples from the first 3 rows or last 3 rows? Do you think it is rational? Not at all. So for this toy example, we take index 0, row number 1. Index 50, row number 51, the first versicolor. And row number 101 means index 100, first Virginica. We take those 3 rows out. We train our model based on those 147. And later we are going to test and see how accurate our model is. You got the scenario? If you don't mind, please tell what the scenario is to your neighbor, because there is a chance that our friends are having a little bit problem of understanding this one. Okay, can I have your attention? Look at here. We say import NumPy as NP. We load iris dataset. And then we import scikit-learn and import, well, tree from scikit-learn. We say, let's load iris dataset into a variable named iris. And the test indices would be first row, row number 51, and row number 101. And now you know what I'm talking about, huh? This is super simple. We say whatever the original iris data set is from the target. What's the target? Label, last column. Delete those test indices, means delete those intentionally. I changed the color to green, means delete this 0 green, this one green, this 2 green. Does that make sense? And in the next one, we say, hey, I want to go to the original iris data, and I want you to delete the whole data part, yellowish color we have here. Delete this index 100, delete, sorry, these 4 columns, and delete these 4 columns. Huh? Because we delete the whole row, we say axis equal to 0. The whole row, right? Yes.
We not, or should we not do that in one line?
In slide number 4, not this week, we are going to learn how to do it in a standard way. But this is just, let's do something to say we have training, we have testing. Huh? Good question. So now we have those 3 lines separated as the test, target, and data. And the rest would be the training. Look at this. We say go to the original data set, those 3 indices, place them into test, target, and go through those 3 indices and place them as the label, the last step. So long story short, we split it into 2 parts, test and train. And now it's the time to treat like the way that we treated our apple and orange data set. We say, let's have a classifier. Let's create an object based on tree library and decision tree classifier. And look at this part. We say, this is the training algorithm. Go to that CLF, fill that box of rules to see what is the pattern that relates these columns of data into these targets. Does that make sense? Like, do you remember bumpy 170 and so on? It's exactly like those 4 columns. And if it is setosa, versicolor, or virginica, find the patterns. Huh? And then after this, we want to just open one. And this is a question that if somebody paid attention thoroughly could answer. Look at this. If I say print test underscore target, let me just type it here. Oopsie. I'm sorry, this is the actual thing. If I say print test underscore target, is it based on calculation and prediction or not? Is it based on calculation, prediction? Anybody else? Yes. Prediction, okay. Matthew, you wanted to say something? I saw a hand. Yes, Ali? Prediction. Let me ask you something. We say test target. Again, look at this one. We say test target. What was test target? Let's go higher. Test target was those indices last column that we had. We go to those indices, index 0, index 50, index 100, and get the last column. Where is the prediction? You know what I'm saying? It is exactly like taking these values, this green value, this green value, and this green value. Does that make sense, everybody? Huh? Look at this one. Now, I want to do the prediction. And Meha said correctly, but to his friend, to our friends, yes, sorry. What's your name, sir? What you said? Meha Jayesh. And now we say based on the data, based on those yellow cells, predict. And guess what, guys? Based on the result, what can you say? It works, yes, but the way that you said deserve one bonus point at least. Yeah. But what is the conclusion? Sorry? The calculation, well, the prediction is the same as the actual labels, right? Say it in a kind of data science format. The accuracy is 100%, right? Because the labels are exactly equal to predictions. Life is not like that. If you run your algorithm and see that for several scenarios, the precision is 100%, you're doing something wrong. Right? And I had that model in one of the students, it was a capstone project that I was managing. And one student said, Reza, in all the scenarios, I get 100% accuracy. I was like, and I saw that he had another version, another scale of the label among the columns, among the features, means that the algorithm found, I don't need to take care of anything else. I'm going to look at that just column. Imagine that we have setosa here and we have zeros here. They are the same. So it says that I don't care about anything else. I just consider that. So again, let's go to the next slide together. I provided some extra slides for those friends that they want to work with Anaconda or PyCharm, Visual Studio Code, or so on. To show the visualization, you need to install GraphViz, but if you work with Google Colab, you don't need to install anything. Everything is already installed. So these are the steps that you need to, yes, GraphViz installation, where to go, what to install. If you're using Google Colab, feel free to skip all these parts. If you work with other environments, you need to just review them. Sometimes when you install a wrong version and you need to uninstall it. So next slide, I say that what are the commands that you need to uninstall those packages and reinstall them. Anyway, everybody, please go to slide number 34, please. And in slide number 34, sorry, 33. In the node part, these 4 lines, Control C. Always we need to have a kind of buffer like this. Is it an important file? Yes or no? Let me just open something else. Okay. And then just add those lines. And look at here, I don't have anything. And I run. Oh, no. Sorry, guys, I made mistake. Slide number 35. And just be careful. Here I mentioned D colon something. Forget about all those things. Just say iris 01. And when you are done, run it, please. Nothing would happen except just wait for a few seconds. And you see on the left side, you're going to have iris 01. Yes. Okay. Slide number 35. 35. And don't worry about the content of the slide. I mean the code. If you could get the same result like iris, double click on it, and you need to download it. And if you, where is the, if you double click on this one, it's going to show you a kind of black and white version of the graph, right? I didn't like this one very much. Please, everybody, instead of that, go to the next slide, slide number 38. And from import pi.plus all the way to the end. And please make sure that you change D colon Dropbox, so on, just to iris 2. It's going to be something like this. And if I run this one this time, look at the left side after a few seconds, we are going to have iris 2. And I'm going to download it. Double click and see the result. Okay. Everything is fine so far. I made something just that's very low quality, but please accept it. I just copy and paste from different. This is line number 1, index 0, index 50, and index 100. This graph shows how decision tree creates the decision tree, those kind of if else conditions behind the scene. Let me open this. And at the same time, I'm gonna resize this and put it somewhere. Can you please tell me for the first one? Oh no. For the first one, it says that the pedal width, if it is less than 0.8, then go to the left side. That's the true. For index number 0, is pedal width 0.2 less than 0.8? Yes or no? That's fantastic. Almost no one pays attention. Okay. Simple question. 0.2 less than 0.8? Yes or no? Okay, then it is true. Then it is Setosa, the first row, and it is correct. How about the next one? Row number 50. Is 1.4 less than 0.8? Then we go to the right side, false. Then we say pedal width. Is pedal width 1.4 less than 1.75? Then true, we go to the left side. And in the left side, what is the value here? Is pedal length this one? It is 4.7. Is 4.7 less than or equal? Yes, then go to the left side. And in here, pedal width, this one, 1.4. Is 1.4 less than 1. Yes, and then we already get to the leaf point, the leaf node, and it says that it is versicolor, which is absolutely correct. Versicolor. Does that make sense? As a practice, just I'm gonna bring this one in the middle of the. For the last one, spend a few seconds with your friend if you already have that PDF and trace it, see if it works fine or not. If everything is fine, please give me a signal, then I can just thank you. Awesome. Let's wait for a couple of more seconds.
this line,
What do you mean?
when I try to add this line,
Uh-huh.
it gives me an error, so I have to remove it.
Which line?
The last one.
The last one, because you have D column or something, you just need to have, look at the thing in here. You just need to have, yes, because you say D and so on, it's going to make it on colon.
Yeah.
Okay,
Thank you.
good question, no worries. Okay. By saying that, we already have all the needed things to understand what actually happens behind the scene is finding these if then else borders, boundaries, right? Where should we put those kind of scale or ruler to say less than this amount, it is versicolor, less than this amount, it is virginica, or check other conditions as well. Let me see if there's anything else in the slide. And yes, I have mentioned a practice that you need to go, and that is something that we did together. And I said, just use the last one as your practice. But the other thing that I want to talk with you, and that's the lightest part of today's session. So I knew that all of us are going to be run out of the power. This one is more fun, not hard to grasp. Many of the content that I provided, I borrowed from Josh Gordon, and he said a nice quote. He said, classifiers are only as good as the features you provide. In other words, if you just ask for something that the data is not inside the data set, it's not possible to expect computer predict something that you haven't talked about. Look at the next part. This is something that we worked in the first Hello World sample, apple and orange. But right now, we want to work on something different. Let's have a data set of different Labradors and Greyhounds, and we want to predict based on the features which dog is Labrador and which dog is Greyhound. This is something, especially when you want to graduate in master or PhD level, one of the biggest challenges is finding actual data. And it is not easy. And if you know that, for instance, I don't know, SickKids Hospital could provide you data, but you have to go through lots of steps to access it. And it's not the best, but you generate random data yourself. So now we learn how to generate random data for these two breeds of the dog. Imagine that among all the features, we want to pick just two. One could be the dog's height, and the other could be the dog's eye color. In this toy example, we consider Greyhounds are 4 inches taller in average, right? So for instance, they are like in average 28 inches, while the Labradors are 24 inches. Is it clear? I'm saying in average. We could have some labs that are higher than greyhounds, but in average 4 inches taller. I'm talking about the greyhounds. But look at the second feature that I've chosen. Regardless of the breed of the dog, there's a 50% chance that the color of the eyes of that specific dog is brown, or 50% chance that it is blue. Do you think it's a good feature? Answer it later. So this is what I said, 28 inches, 24. And the other thing is, imagine that we have only blue eyes and brown eyes among the dogs, right? Everybody could follow this so far? Yeah? Now we want to generate those random values. Considering that we have different breeds of the dog. For instance, Labrador could contain golden retrievers and many others. The same applies to greyhounds. In one of the classes, one of the people said, Reza, this one is not greyhound. I was like, okay, sorry, the door was open, he jumped in. So I think that these two categories, we have different types of them, different heights, and to generate a random 500 greyhounds and Labradors, we use this formula. Somebody tell me, what is random rand n? Yes. Not very random numbers. It's a specific type of random, but what is that a specific type? Pardon? It is an array, but my specific concern is why it is rand n. Yes.
It's 0 and 1, the random of 0 and 1.
That is normal random, but why it is rand n? Rand n generates random numbers that the center would be 0. So it's going to be some positive numbers, some negative numbers. It could be negative 0.2. It could be positive 1.3, right? And you multiply it by 4 plus 28, multiply it by 4 plus 24. Because it could be, for instance, negative 1 multiplied by 4 plus 24. It's going to be, for instance, 19 point something. You know what I'm saying? So you're going to have a good range of numbers, but the average of these 500 labs would be 24, and the average of these 500 greyhounds would be 28. Does that make sense? I don't think everybody grasped that, so please explain it to your neighbors. K is equal to 2, so K nearest neighbors, please explain. Okay. Okay, while you are talking to your neighbors about that, let me just take care of your blessed presence. Okay, getting back to where we left off. If I made a histogram of these numbers, these 500 Labradors and Greyhounds, the result would be something like this. So please tell me, your graph could be a little bit slightly different because of the randomness that we have. But are we confident in this part? The most left, that any dog in that area should be Labrador? How about this one? Yes. How about the next one? In the next one, in the third column, still you can just say with high confidence that the dog is Labrador, but there's a slim chance that it is Greyhounds too, right? How about the most right? You can be very much confident for these three columns still, even the fourth one, that high probably it is Greyhound, the dog that you pick, right? But the problem goes to the middle columns, the center. Can you be confident saying that the dog in here is either Labrador or Greyhound? We can't. Let's get back to another feature that we had. We said height plus the other feature. What was the other feature? Eye color. And I said regardless of the breed of the dog. We have 50% chance that the eye color is brown, 50% chance that the eye color is blue. Okay, one dog jumps on this table and I look at the eyes. Blue. Greyhound or Labrador? Tell me. I repeat again. The chance of having blue eyes and or brown eyes, regardless of breed of the dog, is 50-50. What does it mean? Means that, yes, Ali,
I'd say add more features for people active though.
we need to add more features. So this one, you mean, gives no information, right? Because, okay. Let me tell another example. Imagine that we have 50% of the class domestic and 50% international students. Is it clear? Example. We have 50%, 50%, right? And regardless of the type of the students, we have 100% acceptance in the final exam. What can we understand from it? Technically nothing. We can't say, okay, there is this one student, okay, did you pass? Yes. So you should be international. Can you say anything about it? No. It tells us nothing technically. Useless. Am I right? I just want to tell you that not all variables values are valuable. Okay, so this is, I used Anaconda, the previous one I used PyCharm if I'm not mistaken or something. So I used different environments to show you that the results would be similar. And we already talked about this, that we are confident about the sides, but we have lots of doubts about the middle. And then, guys, can you come up with some other features for dogs? Yes, and
Per length,
Berlin, for instance. So
ear size, knows if it's pointy or if it's flat.
leave something for others to get bonus. Good job. Yes, Sabrina. Okay, awesome. What else? Yes, Ali.
Very specific, bone structure.
Sorry,
Bone structure. That's very specific. Bone structure.
bone structure. Wow. That's a good one actually. Keep with that. I want to talk about this. confusing. It's, you wanna say size of? Oh, weight scale, okay. Because some people say, for instance, the size of ears, or the size of tail, or the hair size, fur size, hair or fur? Fur, right? Okay, Ali?
Here, that.
Yes, ear length. And because, for instance, you see how fast they run, right? Or yes,
Behaviors.
it could be yes. For instance, friendly labs are the most friendliest. Yeah. The friendliest type. Anyway, getting back to that eye color. So you see 50-50 chance of different colors here, 50-50 chance here. So technically it tells nothing. So in that case, we can come up with this idea. Okay, if it doesn't tell anything, toss it away. Don't use it. So avoid useless features. But one suggestion, guys, we have height. Height was useful, right? So because it is useful based on 28 inches, 24 inches, can we say, let's convert this, can anybody just multiply this by 2.40, I'm sorry, divided by 2.54? Oh, sorry, I have to multiply, not right. Multiply by 2.54, it should be 70 something. 71, and how about this one? 60? 6, okay. So how about this? We convert all the values that we have in inches and make another column based on centimeters. I want to tell there are 3 possibilities. This is going to be useful. This is going to be useless. This is going to be harmful. So ABC. So how many of you say A, useful? This means that I'm not sure. 1, 2, 3, 4. So some people say it is useful. How many say useless? 1, 2. 1.5. Useless. So how many of you say harmful? You said useful as well, and now you said harmful. I'm going to give you one negative one. Those people that they vote for both parties. Okay, no joking. So Peter and I know you're kind-hearted. You don't want anybody to be disheartened. So, Owen, where are you? And Peter, actually, correct. It is harmful, but the Mahyar, if I give you bonus mark, people are going to say that it's your cousin, which is correct. So Mahyar. Like a verb. Okay, who else? Okay, look, why it is harmful? Yes.
I want to say, like, why is it not useless? Because, like, it's like saying you're walking or going 100 kilometers and going 60 miles. It's the same.
Excellent. I'm gonna tell you why. It gives double credit to a column you have already received enough credit for it. Okay. The problem is not all, I can say most of the algorithms are not wise enough to understand that, okay, you already have this in another format before. so it gives extra credits. Yes,
Isn't it like correlated to each other, even if it's two?
If I talk about that, I have to talk about the matrix that we have, confusion matrix or not, but you are absolutely right. Yeah. Okay. What two features, for now, it is enough to just say, if two features are very much related, it's better to just drop one. We say independent features are the best, means if you have something like centimeter, inches, they are the same, so don't use them. Just pick one. One other question I have for you. Imagine that I want to predict how much time it takes to receive a parcel, to receive a package from Vancouver. You know how much time it takes to receive a parcel from Quebec, for instance, Quebec City. And you want to say, based on that measurement, I want to predict the time of receiving the parcel from Vancouver. What do you use for that? Do you use a straight line or you use coordination? Yes, Ali? Coordinates. Why?
Because straight line is not accurate. Of course, straight line is whereas straight line is very.
Okay, good. Awesome, Ali. Thank you. How about this? Let's just talk to our neighbors, say which one they prefer. Maybe some people say a straight line, and they have their own reason. So talk to your neighbors, say, what do you think, coordinates or straight line? And for each of them, pros, cons.
Like A and A, but it doesn't understand A and B.
I'm gonna explain. You know time. Let's just have a discussion among friends. Yes? Okay, just a few seconds. We finished the class in 5 minutes or something. So, yeah. Yes?
Straight line is more 2D. Coordinates is like more 3D, so make more sense to use coordinates rather than just a straight line.
Okay, if I give you, just Ali, one quick question. I'm just fabricating. If I say that the coordinates in Toronto is 5, 4, 3, 6, north, and 3, 8, 7, 1, east, just saying. And for Vancouver, these numbers are, I don't know, 3, 2, 5, 1, and 4, 1, 32. How do you feel? I don't know about you, but I freak out. Right? What are these numbers? But if somebody tells me that it's 2,500 miles, isn't it easy to understand this? You're right about the accuracy, but I'm saying that it's computers like us. If something is hard to perceive and calculate, we prefer, there's a slight tiny difference between downgrading and simplifying. If it is possible to simplify it, do simplify, but don't downgrade. So look at this one. For instance, we have a straight line, which is 2,500 miles, sorry. And then we have coordinates. Those are not correct numbers. So this is complex. The best is to use simpler. If I want to summarize what we learned from PowerPoint number 3, we could say the best features are informative features, independent. For informative, always remember like dog's eyes. What is not informative, like eye color. Independent, like not height into inches or centimeter to colors. And simple straight line compared to coordinates. And next week we are going to, next week is reading week. After reading week, we are gonna work on slide number 4. My whole intention was to give you most of the prerequisites. I can tell, like you have already 60–70% of what you need to finish your assignment. But not a bad idea to go through slide number 4, and after the next lab, still we have 1 day. It's not going to take more than 2 hours to finish both, but start work on it to learn, and that's pretty much it. Is there any concern, any question about the marks? Everything is fine. Awesome, and everything is clear for the midterm, so it's going to be 21 MCQ questions, and please, you need to come to, on Monday, you have to come to the George Brown. Yes, first, second.
Simon, so you on November 1st, right?
Sorry?
Simon, you on November 1st.
As far as I remember, it was Wednesday after the Wednesday after the midterm. That's what and we are gonna get there, and you may say, Reza, I need 1 more day, so don't worry about it. If you need 1–2 more days, we can get that. You had a question on?
But the 321 is like a massive convention hall, right?
Yes. Yeah. One of those. Okay, thank you very much, guys. Have a good one. See you.